All right, now let's talk a little bit about reactivity. So, reactivity, and this is something we saw in the first lab experiment where we put the effervescent tablets and it reacted with the water. Right, all of a sudden you saw bubbles and you saw temperature drop, and so it was basically the effervescent tablets reacting with the water. Right, so reactivity is just the ease and speed with which an element combines or reacts with other elements or compounds. Right, so in this case that you see right here in this GIF, it is pure sodium reacting explosively with water. And the reason it does this is because usually, especially when it's an atom that only has like one or two electrons on its outer shell, it wants to get rid of those as soon as it can, right? It's real easy to get rid of two electrons than it is to go and find a bunch of other ones. And this is where I will bring this up right here, is that it's important to know that all electrons or all atoms, what they're really like striving for is to be stable, is to be balanced, right? And in order to do that, they're going to have to reach let's see, they're going to have to reach the octet rule, right? And what the octet rule is saying, and we'll talk about this quite a bit more, especially when we get to bonding, but what the octet rule is saying is that an atom, uh, how do I phrase this? An atom wants 8 electrons in its outer shell. Right, so that's basically what the octet rule is saying. And let me kind of expand this a little bit. An atom wants 8 electrons on its outer shell, and that's the maximum that it can hold in their outer shells. Oops, and I don't know why lowercase that, but anyways, yeah, that's the maximum that it can hold in its outer shell. There's two cases where this is not going to happen, and that's in hydrogen and helium, but that's because it only has one shell. And the rule is technically, and again, we're going to cover this in more detail, the first shell can only hold a maximum of 2 electrons. Every other shell after the first shell can hold a maximum of 8. Right. And that's what they all want to get to, is to reach that full shell in order for them to be stable, to not want to react with anything else. And so the reason I'm mentioning this is because right here you see that reactivity is just, again, how quickly they bond with something else. And atoms that only have 1 or 2 electrons on their outer shell, so like this example again, right here, sodium, right? So sodium only has one electron on its outer shell. So it's going to be very easy right here for this atom of sodium to get rid of this. And that's why it reacts so quickly, is because, and that's why it reacts explosively, is because it's so easy to just get rid of this one electron on its outer shell that it reacts very aggressively, I guess. And that's why you see that flame go up. Because here is pure sodium, right? That's what this bullet point is saying. Pure sodium reacts explosively with water. This right here is sodium, right? Na is sodium. So that's why you see it reacting the way it does, is because it's getting rid of that electron as fast as it can. Right. So what you'll notice here is that families, so right here, groups or families have similar reactivity, right? So they react similarly. So again, these right here react the way they do because they only have 1 or 2 electrons on their outer shell, right? Again, that's why there's a 1 here, and that's why there's a 2 here, because again, these only have 1 electron on their outer shell. These only have 2 electrons in their outer shell. And because of that, they want to give them up so quickly that they will react violently when they get together with something that they can react with. And again, the ones up here in the metals, they're going to react more violently with water than most other elements. These over here, on the other hand, you see it has an 8 right here at the end. And so the number up top is 18. But again, you don't really focus too much on the 1. You focus more on the second number, in this case, the 8. And so what I was saying is that they're all trying to reach that full shell, right? And I said the only exceptions are helium and hydrogen because they only have the one shell. So let me go and show you this again. Right here, the helium and the hydrogen, they only have one shell. It only has one shell, right? So this one has a maximum. It has 2. This one can still use another one, right? Because again, the max for the first shell is 2. All the other shells are 8. And so this one has its full first shell. This one has 8 in its outer shell. This one has 8 in its outer shell, 8 in its outer shell. So all of these will not react with anything because they already have their full shell, right? They don't want to react with anything because they're good. So remember, the octet rule, they're trying to reach their full outer shell. For most of them, that number is 8. For hydrogen and helium, that number is just 2. Because again, first shell can only hold a maximum of 2.